Hello guys, welcome back to our channel Apna Tutors. So today what we are going to do is we are going to complete our exercise 1.1. Hope so everything is going fine till now. If you have any doubt you can reach out to me by mentioning me in comment. Then I will try to sort out your problems. Okay, so without wasting time let's move forward. So next question is question 12. What is there in that? So that relation defined in the set A of all triangles. Set universal set is set of all triangles, and relation is defined as T1 and T2 are related if T1 is similar to T2. Again, we have to show it is equivalence relation. We have did this in whole exercise, so again we have to do that same only. Then further part is consider three right angles triangle T1 with side 3, 4, 5, T2 with side 5, 12, 13, and T3 with side 6, 8, 10. Which triangles among T1, T2, and T3 are related? That we have to find. Okay, so let's do it quickly, as this is now very easy, right? We had did it many times. Okay, so let's start with first reflexive. So I think you can easily guess why it is reflexive. Why it is reflexive? Because T1 is of course similar to T1 is T is similar to T for any T belongs to A, where T is any triangle, as A is a set of all triangles. So as T is related to T, this will implies T comma T belongs to R. For every T belongs to A, this implies R is reflexive, right? So we are done. Let's do symmetric part now. Why it is symmetric? I will do quickly now. Okay, this is now our usual task. We are doing in every video this. Symmetric. Why it is symmetric? As T1, let T1 comma T2 belongs to R, which implies T1 is similar to T2. But this also implies that T2 is similar to T1, right? So this will implies T2 comma T1 belongs to R. So are we done, right? That we had shown T2 comma T1 belongs to R. That's what we needed for showing symmetric. Now let's show transitive. Again, transitive, same way. Let T1 comma T2 and T2 comma T3 belongs to R, which implies T1 is similar to T2 and T2 is similar to T3. As by property of similarity, T1 is similar to T3, as T1 similar to T2 and T2 similar to T3, and similarity have transitive property. So this gives T1 is similar to T3, which implies our R is transitive. So we are done, right? We have shown that it is equivalence relation. Now let's next saying that we have to find whether T1 is related to T2 or T2 is related to T3 or T3 is related to T1. So I can clearly see that 3 ratio of 3 with 6 is same as ratio of 4 with 8 is same as ratio of 5 by 10, right? 5 with 10, which shows that by side ratio side similarity, we can say T1 is similar to T3. This was easy, right? So we said that we can say that T1 is related to T3. T1 and T3 are related. So we are done with this question, right? So let's move to next question. So what next question is saying? So that the relation defined in the set A. Now our set A is set of all polygons. As P1 comma P2 belongs to R if P1 and P2 have same number of sides, and we have to show this is an equivalence relation. Now you show, okay, this is equivalence relation. It's very easy now, and we have to show what is the set of all elements in A related to a right angle triangle with side 3, 4, and 5. So let P be triangle, in fact right angle triangle, with sides 3, 4 and 5. So we have to find, now I can say, right, because it is equivalence, so I can say class of P, equivalence class of P, because the way they are saying that we have to find set of all elements in A related to P. This is what equivalence class of P means, right? We did this in previous questions. So what will be the equivalence class of P? All B belongs to A such that P comma B belongs to R. I can write B comma P belongs to R also. Why? Because it is equivalence relation. So if P comma B belongs to R, then B comma P also belongs to R. Okay, this is just, I am saying that you can write it in equivalence class, you can write it as this way also, and you can write it as this way also. It doesn't matter which one you are writing as first, because equivalence class is for equivalence relation. So of course it will be symmetric also. Okay, so B belongs to A when two triangles are when two polygons are related according to this in these are when they have same number of sides, that is P and B have same number of sides. Now can you tell me what will be these sides? As P have how many sides? P have 3 sides. And what is 3 sides polygon is called? It is called triangle, right? So B will be related with P if it have 3 sides, that is if it is triangle. So it will be collection of all triangles. I can write it as, that is collection of all triangles. Right, you got it, right? What is this set means? Set of all element in A related to right angle triangle. Here right angle triangle doesn't matter, even the length of the sides doesn't matter, because we only want how many sides are there. So there are 3 sides. So which elements will be related to P? All the polygons which have 3 sides, that is all the triangles. So we are done, right, with this question. Showing equivalence is your homework. Okay, this is homework. Okay, so let's move to next question quickly. Okay, so what is 14? Let L be the set of all lines. Now it is line in the xy plane, and R be the relation defined as R will contain pair L1 comma L2 if L1 is parallel to L2. We have to again, so this is an equivalence relation. It's easy. Now you can show, I think, find the set of all lines related to line y equals 2x plus 4. Okay, so first part you will show, I think, that showing equivalence is easy. Okay, I will still give you some verbally some idea why it will be reflexive, because if you are taking any line, then of course that line is parallel to itself, so it is reflexive, right? L comma L will belongs to R. Now L1 comma L2 belongs to R, that is L1 is parallel to L2, but that also means L2 is parallel to L1, so it is symmetric also. And why it is transitive? Suppose L1 is parallel to L2, that is L1 comma L2 belongs to R, and next you suppose L2 comma L3 belongs to R, that means L2 is parallel to L3. So L1 is parallel to L2 and L2 is parallel to L3. This means L1 is parallel to L3. This means it is transitive. So we are done. We have shown the equivalence relation. Okay, let's do next part, that is find the set of all lines related to line y equals to 2x plus 4. That is, we need to find the class of y. So okay, let me first, what does mean? Okay, let me first write a definition of equivalence class. All B belongs to L, that is B is line such that B is, writing B comma y belongs to R is same as B is parallel to y. Now can you tell me when two lines are parallel? Let me show it in coordinate plane. Suppose I am having some random line like this. So when another line will be parallel, line this space, say L1, suppose this L2 is parallel to L1. When will it be parallel? If slope of L2 equals to L1. I think you know this, right? That two lines are parallel if their slope are same. Okay. Okay. So as B is line, so how it will look? Something like mx plus c. This is the standard definition of line, right? Then mx plus c is parallel to 2x plus 4. And what is slope of 2x plus 4? It is type of mx plus c, so slope is 2. This is slope of y. So it will contain all line mx plus c such that m is equals to 2. So we are done, right? What elements are related to y? It will contain all line of form mx plus c such that m is equals to 2, and c is any constant here. You can write it here also, where c equals to constant. So we are done. Constant in R. Okay, so we are done, right? We had shown the equivalence class of y. So let's move to next question. Okay, now these two questions are homework. Still, I will give some idea what to do. Let R be the relation in the set 1, 2, 3, 4. This is your universal set. This is R given relation, and you need to identify whether it is reflexive, symmetric, and transitive. Okay, so reflexivity is 1, 1, 2, 2, 3, 3, and 4, 4 are there. So it is reflexive. Now similarly, you see whether it is symmetric and transitive. I will not do whole question, otherwise you will not be able to learn it. Okay, so next question is, let R be the relation in the set N given by a pair of A comma B such that A is equals to B minus 6 and B is greater than 6. Then choose the correct answer. We need to identify whether 2, 4 belongs to R, 3, 8 belongs to R, 6, 8 belongs to R, or 8, 7 belongs to R. First of all, two conditions are given, that is A should be equals to B minus 2 and B is greater than 6. So first of all, A option will not be there, right? Because 4 is not greater than 6, that is this B should be greater than 6, but it is not. So you have to verify these three options only. Okay, so let's see whether B is there. For 3, 8, 2 belongs to R, 3 should be same as 8 minus 2. 8 minus 2 is 6, which does not equals to 3. So this is not true. 6 should be equals to 8 minus 2, which holds 6 is equals to 6. That means C option is correct one. This is also not correct. So we are done with exercise 1.1. Hope so you are doing some good practice. If you will do some good practice, you can catch even every questions of this type. Surely there will be one question of this type, whether you would be asked to find whether relation is reflexive, symmetric, and transitive in your exams. Hope so you will do it now. I had shown you every way to look at it. By I think various types of things can be involved in this, like they can put geometry also, they can put limit also, they can put continuity also, by saying that two functions are related if two functions are continuous, if their limits are same, they are related. In that way they can make many type of this question, but your basic is clear now, that how to show that whether it is equivalence or not, because in this whole exercise we did this only to see whether relations are equivalence or not. So hoping you will do good in your exams when this type of question will come. So in next videos we will try to cover the exercise 1.2. Maybe exercise 1.2 is having functions related part, so we'll do that. Okay, till then have a good day. Thank you.